The second equilibrium problem is very, very similar. In fact, it's virtually identical. The only difference is the level of math. So I'll redraw the picture so we have a good reference. Let's see what we have. We'll keep the mass at 50 kilograms. And we have a couple of angles, not to scale. 38 degrees and 41.2 degrees. So we're going to approach this the same way. Free body diagram about the knot. So, our set of axes. Draw some forces. So we have A leaving the knot. Got to be careful. This angle was resolved to the vertical. So if we look at what this angle should be, it should be 52 degrees. Why? 52 plus this angle, which is what was given, 38, is 90. B, (41.2 degrees from the Z rule again. And once again, since it's a 50 kilogram mass, we are going to end up with 490 newtons yet again. So what do? Same as last time, resolve into components. X component, A cos 52. Y component, A sine 52. X component over here, B cos 41.2. And then the Y component, B sine 41.2. What you might want to do, once you start seeing a lot of different vectors drawn, is to use different colors when you're drawing X and Y components. I can't do that with my pen, but I can at least underline things. For example, or put boxes around them, I will underline all the X components and maybe put stars or something by everything that is a Y component. Because now what I can do is decide or realize that everything that is underlined should be in one equation, everything that is starred should be in another. Anything that does not have an underline or a star belongs in no equation. So, let's take a look. Sum of the forces in the X is 0. Sum of the forces in the Y is 0. Same as before. Positive X, we have an A times the cosine of 52. It's the only positive. Negative X minus B cos 41.2 equals 0. Don't forget the equals 0, so we have an equation. Once again, if you've noticed, I did not use the standard angle. I used the reference angles. Same thing with Y now. A sine 52 plus B sine 41.2, it points up, minus 490 newtons equals 0. 80% of the credit is done. There is no more physics. It's all math. So what's the difference? In this case, both of the equations have two unknowns. So we have to decide which one to work with first. So when we do work with one of them, we're not going to get a numerical answer to substitute in the other one. We're going to get an expression. The easiest one to work with is X because there are two unknowns but only two terms. Y has two unknowns and three terms. So I'm going to solve the X equation for A. A cosine of 52 equals B times the cosine of 41.2. A is B cos 41.2 over the cosine of 52. So A is 1.22 times B. Cosine of 41.2 and cosine of 52 are simply numbers. When you divide them, you get 1.22, and you still have a B left. The principle of simultaneous equations. Solve and substitute. This is what A is. There's an A over here. It's times the substitute. Be very careful when you do. A is 1.22B, but you still have a sine of 52. plus B sine 41.2, no B on the 490, equals 490 newtons. Now we can shrink it down. This 0.961B, this 0.659B equals 490 newtons. We still have to keep 3 sig figs because really we have some combined operations here. So when we add them, 1.62B equals 490 newtons. And now we can get B, when we divide, as 302 newtons. To get A, back substitute. A is 368 newtons. And again, our brief check, they're both positive. Just look and realize this problem is no different than the previous one in terms of physics. The 80% line ends here. All the physics is done. The only difference is a little more math.